Welcome friends. Now I am going to discuss about how to construct the heap, that is construction and insertion and deletion. Insertion and deletion into the heap. So now suppose I have these are my elements. Suppose my elements are 10, 20, 15, 30 and 40. So now what I want to explain you, I will explain how to create the heap and what is the time complexity for that, and how to delete the elements, and the most crucial operation is that is Hepify, and the last is after Hepify we will go for the heap sort and priority queue. Regarding this, I would like to say that whenever I am inputting the elements, suppose these are my elements, I want to input this. So whenever I am inputting first element, suppose that is 10, and I want to represent it like this. This is my array, and array representation having 5 elements, I have to input only 10, and that's it in 1th index, 2, 3, 4 and 5. Here you should have to count the index as 1 for your learning purpose. So after inputting 10, how you will construct the other heaps like that I want to show you. So when you will insert 20, suppose this is 10 is your first element and you want to insert 20. Now you have to check simply 10, 20 you have to insert, and this is 1, 2, 3, 4 and 5, and you have to compare the elements along with your parent elements. As I have already told in my previous class that if element is in ith position, then its parent is in I by 2. So 2 by 2, that is 1th position its parent, so these two will be compared. And if you want to create a max heap, then the maximum element will be in the root, so exchange will be happen. Then this will be 20 and this will be 10 if you want to create a max heap. Now if you want to insert 15, then this is your 10 element and this is your 20. Now you want to insert 15, whether it is, if you will insert this, then this representation is like this: 20, this is your 20 and this is your 10. Now you have represented 15. So 20, 10 and you have inputted 15. Now what you have to do, you have your index is now like this 1, 2, 3, 4, 5. Now this third index is your element you have inputted, and this element you have to check with its parent. Its parent is placed in 3 by 2 element position, that is in 2 position. So sorry, that is in 1 position, 3 by 2, that is floor value we have to take 1 position, its parent is checked. So you have to check whether it is greater than its parent or less than its parent. If it is less than its parent, no need to do anything. Then we will input like this. We have inputted 10, 20, 10 and 15. Now my array size will be like this: 1, 2, 3, 4, 5. Elements are here just like 20. Here it is 10, 15. And the third element you want to input, the fourth element, that is 30. So you have to input it like this. So whenever you have inputted 30, then what will be the position? So 30 will be placed here. So if 30 is placed in 4th index, then you have to compare its parent. 4 by 2, that is in 2 parent, 2th position its parent is there, means 30 will be compared with a 10, and if it is bigger, then it will be exchanged. That means here in this case it is bigger, that means 30 if you place here, its parent is 20 and exchange will be done. So here what you have to do, you have to put 30 here and you have to put 10 here. After that what will be happen? The 30 will come to its parent position. Parent position means wherever its parent is there, you have to compare with this. So 30's parent value is 10, so 30 will be compared with 10, 10 will be come to its initial position, 30 will be again that this 30 will compare with parent. So this is greater, so 30 will come to here and 20 will come to here. Now what will be happen? Now you are in the root, so whenever you are in the root, no comparison need to be done. Now what will be happen? Your present representation is, this is 30, this is 20, this is 15, then 10. Now the next element will come, that is 40. So where it will be placed? So it will be definitely placed here. So if you will place here 40, then what will be happen? You have to compare with its parent. It is in 50 index, so 50 index means its parent value is at I by 2, that is 5 by 2, that is in 2th place. 2th place is who? That is 20. So 40 will be compared with this 20. So that means if you will place 40 here, then this will be compared with 20. So once it will compare with the 20, then 40 will be replaced here and 20 will come to this place. So then what will be happen? So 40 will come to this place and 20 will come to this place, and after that 40 will compare with along with its parent, and 40 will go to here and 30 will come to here. So now finally what will be happen? So 40 will be here, now 30 will be here, and 20, this is 15, this is 10, and this is 20. The representation is like this, then it will be 40, 30, then 15, 10, 20. This is 1, 2, 3, 4, 5. This is the way that we are creating the heaps. So if you are creating the heaps like this, now it tell me, once you will create this heap, then how much time it is taking? Now each time we are comparing with log n, the height of the tree. That how many times we are comparing? Now n number of times we are comparing. So for creation of heap, it takes time is equal to order of n log n, if you are considering for creation. Now the question is, after creating the heap, so when you will delete the element, so how could you delete the element? So already I told you that the deletion process. Now let me to explain again the deletion process of a heap and how we will delete it. So now check it. After insertion, we are going for deletion. Suppose my elements are this, and I want to create the max heap like a, first I have created, this is 40, (10), 20, 30, create, suppose my elements are like this, 40, suppose these are my elements, this is a max heap. So I want to delete. So here already I have told you that the deletion can be only possible, that means the root can be deleted. So the deletion process, I already told you that, suppose this is my array representation. So here I have represented 40, then 30, then suppose 20, then sure, here I have taken one more element, suppose let it 25. So 25, then 20, then 10, then 15. Suppose this is my representation 1, 2, 3, 4, 5 and 6. My heap size is up to this. So what I did, I want to delete one element. Suppose when I will delete this 40. So I already told you that if you want to delete one element which is the root, then place the last value of the array into that place. Last value, what is this? The 15 position. So 15 will be replaced by this 40. So what you will do? The 15 will come to this place. So if 15 will come to this place, then this you can erase it. So 15 will come to this place. After that, what you have to do? You have to go for adjustment. So when you will go for adjustment, then you have to go for top to bottom. That means this 30 and 25, who are the child of 15, you have to compare who is bigger. If it is a min heap, who is smaller, you will go to the end. If it is a max heap, as it is a max heap, bigger element will come to the root. So 30 and 25, 30 is bigger, so 30 will be replaced here, and 15 will come to here. So if 30 will be replaced here, so 30 will be here and 15 will come to here. After that, what will be happened? My representation will be changed. That means here it will be 40 is deleted, and here it will be replaced by 30. Then this will be 15. Then this will be 25. Then 20, 10, and this is come to the row. So now this place is vacant. I have deleted 40. So if I will do one thing, that the vacant place what I got and the delete element what I got, I will place it here. Suppose I will place 40 here, but my heap is up to this size. Then which element I will delete? I will delete next element is the next highest element, that is 30. So if I will delete 30, already I told you that if you want to delete the root, then in the array whoever is the last element, that you have to put it. Last element is 10, so you have to put this 10 in place of 30. So in place of 30 I will put 10 and I will delete it. Then what will be happen? Now I have to adjust it as it is a max heap. So 15 and 25, who is bigger? 25 is bigger. So 25 will go here and 10 will come here. Now you will go for again. This is 15 and 20. So 20 will come to here and 15 will be here. Now the representation will be, you have deleted 30. So deletion position will be replaced by your last element, that is 10. So when it is adjusted, now it is 25 and this one is 20 and this one is 10 and this is 15, and you have deleted this position. This is the vacant place, and which element you have deleted? Now 30. So put it this 30 here. Why I am putting this? Now my heap is up to this. I have deleted first 40, then 30. If likewise I will delete the next element, what I will delete? 25. So 25 will be comes to this place. If I will place it in this my free heap, and if 25 I will delete it, then the last element, who is the last element? Last element in the heap is 15. So 15 will replace here, and now we have to exchange 10, 20, or 20 will go here and 10 will be here, 15 will be here. If 15 will be here, then what will be happen? Now we have to, the array will be like this: 20, 15, 10. Now your heap came from up to this. You have deleted these elements. You check it, whenever you are deleting and putting it into the right free places, then this is just in the decreasing order you are putting it. And finally, if you will delete all the elements, what will be happen? You will get an array of sorted elements. That is, here it will be 10, here it will be 15, here it will be 20. And this is called as the heap sort. So that means in heap sort, what we are doing? We are doing first, we are creating the heap, and to sort the elements, either it is a min heap or a max heap, we have to delete the element. If it is a max heap, we are increasing order we are putting it. If it is a min heap, we will get a decreasing order of our sorted array. So whenever we are heap sort, we are creating the heap, then what we are doing? Deleting the heap. Deleting the heap. So if you will create the heap, it takes how many times? It takes in log n times. Why n log n? I already told you that you have to check the height of the tree for log n times, and n number of comparisons are there, n number of elements you are doing the readjustment, so that is why n log n times. And whenever you are deleting the elements also, same number of time you are taking for deletion. If it is n log n for creation and n log n for deletion, then what is the time complexity for heap sort? Heap sort time complexity is n log n plus n log n, that is 2n log n. That you can say that this can be order of n log n. This is the time complexity for heap sort. So now we have already discussed the construction of heap, insertion and deletion. Now we will discuss about the Hepify procedure. So what is actually a Hepify procedure? I will explain you. That means suppose I have the elements like this. Suppose my elements are 10, 15, 20, 25, 30, 40. So whenever I am representing these in an heap, I will not here check any whether it is a heap construction with proper way or not. So simply I will put this into an array. Suppose this is 10 and this is 15 and this is 20 and this is 25 and this is 30 and this is 40. I want to create a max heap. So here the Hepify procedure means here this is also a complete binary tree and this is also a heap. It may be a min heap or max heap, whatever may be, as you have already stored it in a sorted order. So this is a min heap. So now we want to make it a max heap and we have to Hepify it. So Hepify procedure is saying that you have to, then this is my array representation. So you have to come from the right to left. That means you have to check whether this 40 is a complete binary tree or not. Only you have to check 40. Yeah, this is a complete binary tree. Next element is what? 30. Whether this 30 is a complete binary tree or not. Yes. Now you will go for 25. Yes, 25 is a complete binary tree or not. Yes, 25 is a complete binary tree. Next element is 20. So you are coming from this direction, right to left. So whenever you are coming for 20, that means you got that 20 is a parent node, it has a child. Whether it satisfies the max heap property? No, it is not satisfying the max heap property. So what you have to do? You have to exchange these two values. That means 40 will go here and 20 will come here. So if 40 will go place of a 20, then 20 will come place of, this is 20 and this is 40. So you have to exchange this. This is 40 and this is 20. Now I'll say how Hepify is different than other process. Now this is a, now this 40 is a max heap. Yes. Now you will go for 15. So 15, because you are in this place. You are in this place. Now 15. So 15 has the child 25 and 30. Whether it is a max heap? No, it is not a max heap. So what you have to do? You have to compare its children. So 15 children, 15 is in which place? This is 1, this is 2, 3, 4, 5, 6. 15 is in 2th place. So its children will be 2i and 2i plus 1. 2i means 4 place and 2i plus 1 is, that is 5th place. So 4th place, 5th place, who is there? 25 and 30. Definitely these are 25, 30. You have to compare it. Which one is bigger? 30 is bigger. So 30 will replace its parent and 15 will come to here. So that means 30 will go here and 15 will come here. So this 30 and 15 will be exchanged. This means this is 15 and this one is 30. Now what will be happen? Now again you have to check this is a max heap. Yes. Now you will go to its parent. That is, now you are in this place and now you will go to this place because you are coming from right to left. Now you are in 10th place. So this place, that is where, who are the root? Now 30 and 40 are the root. So if 30 and 40 are the roots, because you are going from bottom to left, bottom to top. So 30 and 40 are roots, you have to compare. 10th position, index is 1, its child should be placed in 2i and 2i plus 1. 2i means 2 and 2i plus 1, that is 3. That means 2 place 30, 3 place is 40. So 30 and 40 will be compared, and after comparing this, who will be the bigger? It will go to this place and it will come to that place. So now 40 will go to this place and 10 will come to this place. That means 40 will be replaced by here and 10 will be here. So now which place you came? Now your index value will be now here in 10th place. Now you will check whether this 10 is greater than its child or less than its child. So 10th place index is 3, its a child should be 2i. So 2 into 3, that is equal to 6th place. 6th place value is 20. So 20 and 10 you will be compare. If it is greater than, then it will be changed 20 and 10. So now this Hepify procedure is taking the time complexity for Hepify is order of n only. So in case of heap sort, what you are doing? You are creating the heap, you are deleting the heap. So for creation you are taking time n log n, for deletion you are taking time n log n, total heap sort is taking 2 n log n, or you can say that n log n time. So this is the procedure for heap sort. Now the last concept I want to show you that what is a priority queue. So simply I am telling you, priority means you can take that the lesser number is having highest priority or the highest number will be having higher priority. So priority queue is nothing but we can represent the heap using max heap and min heap, and here in case of max heap the maximum element is the highest priority, and in case of min heap the minimum element is in the highest priority. That means here the element itself is the priority. Suppose I will show you two examples. Suppose these are my elements. Suppose I have 2, 5, 8, 10 and 20. So this I can represent it. This is my 2 and this is 5 and this is 8 and this is 10 and this is 20. So this, in case of a max heap, if I will represent it, then this can be replaced by like this 20 and this will be 10 and 8, 5, suppose 2. So my point is here 1, 2, 3, 4, 5. Suppose we want to explain regarding the last concept, that is the priority queue. Priority means itself the number is the priority. Suppose you want to delete 5, 2 is if it is a, you are taking two cases. One is least element having highest priority. Another one is highest element having highest priority. That is, in this case of is max heap and this case is min heap. So here the priority queue is used to represent the heap, and how it will be used to represent the heap? This is the minimum priority. So if you want to delete the minimum element, then you can delete the minimum element first, which is in the root. So min priority means the least element will be given highest priority. Here in this, these are my elements. Who is the least element? I will delete it first. That means we will use min heap. But if it is case of a max heap, then these elements will be represented like this. This is 20, this is 10, 8, 5 and 2, and the priority for this is highest element having highest priority. Now you tell me, queue principle is first in first out. That means the first element in should be first out. So here who are the representation is how much? This is 2, this is 5, 8, 10 and 20. So which element is first inserted to the array? The least element, as this is the least priority queue, or you can say that mean priority queue. Now if you will delete this 2, now the same procedure you have to follow as like your heap sort. So this 2 you will delete it, and you have to replace the highest element, last element into that place. Which is the last element? That is 20. You have to replace this as 20. And after that, what you will do? After replacing this, you have to adjust this, and it will take order of n log n time. So in case of priority queue also, insertion and deletion takes the same number of time, that is order of 1 to order of n log n. So here after deleting this, what you have to do? Again you have to readjust it. Readjust it as it is a min heap, so you have to check whether these two are who is minimum will go to the top. So now minimum element is 5 and it will go to here, and 20 will be replaced here. Now this 2 element is already deleted. 2 element is already deleted.